Is that right, Lama? Yes. So I do have your previous whiteboard note. අපි අන්තිමට class තිබි 7th නේ? 1 second. අපි atomic lattice කරලා we have written about graphite and diamond and that's about it. We have not really discussed no about graphite and diamond. හරිද ළමයි? මම කිව්වා හරි නේද? We have only written about graphite and diamond. That's correct, right? Yeah? One second, no? Okay, Lama. So let's quickly discuss about graphite and diamond. Let me get the pictures to the whiteboard. 1 second. One second. Okay, so wait a minute. All right. So, Lamai, since we already wrote about graphite and diamond last week, I will just explain this part, right? Can all of you see the picture on the whiteboard, Lamai? Okay, great. So, අපි ලිව්වා about graphite and diamond මෙන්න මෙහෙම. මම ලියපු note එකක් දාන්නම් අපේ whiteboard එකට. This is a note that we wrote. You don't have to write this again. This is something we wrote last week. Okay, graphite. Here, one carbon atom is bonded to 3 other carbon atoms by single bonds, right? So, one carbon atom is bonded to 3 other carbon atoms by single bonds. So, this is a picture of graphite. බලන්න මේ මැද තියෙන graphite atom එකක් ගත්තොත් එයා මෙතන එක කාබන් එකකට මෙහෙම බොන්ඩ් වෙලා මේ කාබන් එකට මෙහෙම බොන්ඩ් වෙලා මේ කාබන් එකට මෙහෙම බොන්ඩ් වෙලා. So it's bonded to 3 other carbon atoms. If you take this carbon, it's bonded to another carbon, one carbon, another carbon, altogether 3 carbons, right? So like that, every single carbon atom is bonded to 3 other carbon atoms. ඔගලන් මේ දැන් මෙයා බලන්න මේ 1 2 3 මේ ඔක්කොම carbon atoms the black dots are all carbon atoms here 1 2 දැන් මෙතන පේන්නේ නැහැ මේ කොටසේ මෙතන 3 කියලා තව කෙනෙක් එක bond වෙලා තියෙනවා. Is that clear to all of you, ළමයි? Is that clear to all of you? Thumbs up. Okay. Now I have a question. What is the electronic configuration of carbon? What is the electronic configuration of carbon? 2 4. 2 4 means carbon has 2 4, right? 2 කියන්නේ අතුල ඉන්න කට්ටියනේ. So there are 4 electrons in the outermost energy level. Right, there are 4 electrons in the outermost energy level. 1 2 3 4. දැන් මොකද වෙලා තියෙන්නේ graphite වල? Every carbon atom is bonded to 3 carbon atoms. Right? So here මේ කාබන් එක මේ ඉලෙක්ට්‍රෝන එක යූස් කළා ඕන එක බොන්ඩ් එකක් හදනවා. මේ ඉලෙක්ට්‍රෝන එක යූස් කළා තව බොන්ඩ් එකක් හදනවා. මේ ඉලෙක්ට්‍රෝන එක යූස් කළා තව බොන්ඩ් එකක් හදනවා. Then can you see there is one electron remaining? ඒ වගේ හැම කාබන් එකකම ඒ වගේ එක ඉලෙක්ට්‍රෝන එකක් ඉතුරු වෙනවා. Did you understand that? Because every carbon forms only three bonds. That means one electron is remaining. Is that clear to you, Lamai? Is that clear to you? Yes. So, ඒ වගේ මෙන්න මෙතන ඉන්නවනේ දැන් carbon atoms කීපයක්ම like here. There's a carbon atom here, 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 like that. There's like one layer of carbon atoms. මේ හැමෝගෙම, if I show this layer using this book, let's say this is this top layer. මෙන්න මේ layer එක තමයි මේ තියෙන්නේ. මේක layer එකක් විදිහට තියෙන්නේ මෙහෙම. So හැම carbon atom එකම එක electron එකක් ඉතුරු වෙනවා. එක electron එකක් ඉතුරු වෙනවා. ඊළඟට මේ යට layer එක ගත්තොත් යට how do I show this? There is another layer. එයාගේ carbon atoms වලින් හැදිලා තියෙන එක electron එකක් ඉතුරු වෙනවා. So මේ layer එකේ the electrons are like this. යට layer එකේ the electrons are like this. So උඩ layer එකේ යට layer එකේ මෙහෙම electrons freely ඉන්නවා. One electron for every carbon atom is not bonded. So it's just freely there. So electrons and electrons, do they attract or do they repel? Electrons and electrons, do they attract or do they repel? Repel, because they are both negative. No, negative හැම වෙලෙම repel වෙනවා. එතකොට මේ layer මේ carbon atom layer එකේ එක electron එක there are like electrons. මේ carbon layer එකේ carbon atom හැම එකකම එක electron එකක් තනියෙන් ඉන්නවා. So there are free electrons. So these two layers cannot come closer to each other. Why? Because මෙයාගේ free electron හැම carbon atom එකකම එක free electron එකක් ඉතුරු වෙනවානේ. So there are so many free electrons. Here also there are so many free electrons. And these electrons cannot get closer because electrons, they repel. So these layers, they will not come closer to each other and they will stay at a certain distance. Okay? Is that clear to all of you? Is that clear to all of you? Because of that, Lamai, graphite will always, this carbon arrangement, the lattice, there are layers and layers. A layers එකක්වත් එක ළඟ එකට එන්නේ නැහැ because electrons and electrons, they repel each other. So they are separated as layers. Okay. So, ඒකයි ළමයි අත්‍තරම graphite වල, if you look at this, if you look at what we wrote last week, right? Last week, these are arranged as layers in the lattice structure. The forces between the layers are very weak. Why? Because electrons, they repel. Therefore, they can slide over each other. Since electrons repel, these layers cannot come closer to each other. ඒකින්ද මේ layers වලට එක උඩ එක slide වෙන්න පුළුවන්. Therefore, graphite can be used as a lubricant. So usually graphite has a very like a slippery texture, right? ඒකින්ද ගොඩක් machines වල එහෙම ළමයි ඔය එකට ඇතිල්ලන කැලේ තියෙන. Do you remember in lesson 5 we talked about friction? Give me a thumbs up if you remember. Okay. So, एक यहाँ पे किया to reduce friction, we can use a lubricant. Lubricant क्या है? Machine वाला parts का तामे machine parts का तामे parts method आप इटे दान पुलवान lubricant लेगा. right දැම්මහම ඒ parts අතරේ friction එක අඩු වෙලා ඒගොල්ලෝ ලස්සනට ලේසියෙන් slide වෙනවා. ඒවට අපිට graphite use කරන්න පුළුවන්. Because මේ layers හැම වෙලේම they can slide on top of each other නේ. So graphite is very slippery. If you take a graphite pencil, දැන් අපේ pencil වල තියෙන graphite නේ. දැන් ඔබලා හිතන්න මොකක්ද ගල් කැල්ලක් ගත්ත කියලා you take a piece of stone or rock. Can you like nicely draw letters using a piece of rock even if you sharpen it? Even if you like හිතන්න මොකක්ද ගල් කැල්ලක් කරනවා ඔයා හොඳට ලස්සන sharp උලක් හදනවා. එහෙම හදලත් ඔයාට ලස්සනට අකුරු ලියන්න පුළුවන්ද අපි pencil එකකින් ලියනවා වගේ? Yes or no? Yes or no? No. It's not very smooth, right? මෙහෙම ඉරිරි ඇඳෙනවා but ලස්සනට smoothly ලියන්න බෑ. හැබැයි when you take graphite is what is in a pencil, right? So in graphite when you write ලස්සනට ලියවෙනවා. pencil එකෙන් ලස්සනට ලියවෙනවා, right? When you sharpen and write, that is because when you're writing from a pencil ඔයා ලියද්දි දැන් මේ carbon layers දින්නේ. ඔයා මෙහෙම හිතන්න අකුරක් ලියනවා කියලා. When you're writing, some of those layers get transferred to the paper. ඔයා pencil එකෙන් ලියනකොට ලියවෙන්නේ මොනවාද? අර carbon layers pencil එකෙන් ගැලවිලා තමයි ඔයගේ පොතේ ලියවෙන්නේ. That's why you can smoothly write. Is that clear to all of you? Give me a thumbs up, please. Okay. Then diamond. That is about graphite, right? Graphite has an atomic lattice. Then diamond. Here, one carbon atom is bonded to 4 other carbon atoms by single bonds. Now, carbon වල ළමයි කොහොමද තියෙන electrons 4යිනේ. ඒතර 4 දෙනාම bonds 4ක් හදනවා. දැන් කිසි ප්‍රශ්නයක් නැහැ. graphite වල වගේ කිසිම වෙනසක් නැහැ. Every carbon atom, there are 4 electrons in the outermost energy level. ඒ හැම electron එකක්ම ගිහලා තව 4ක් එක්ක connect වෙලා. So it's a very strong structure. අර වගේ free electrons එම නැහැ. මේ තියෙන diamond මේක හැම එකකම ලස්සනට පේන්නේ නැහැ, but if you look at this one, 1 2 3 4. Then if you take this one, 1 2 3 4. If you take this one, 1 2 3 4. If you take this one, 1 2 3 4. මේ සමහර ඒවාල හතරම පේන්නේ නැහැ, but if you take like this, 1 2 3 4, 1 2 3 4, like that, right? So because carbon has 4 electrons and all those 4 electrons are bonded to other carbon atoms. So we say diamond has a very strong structure, right? අපි කියනවා diamond තමයි hardest substance on earth. Okay, density මානම වැඩි, අන්තක හරිම hard. Very hard, very sturdy. ඔය සාමාන්‍ය glass වගේ කපන්නත් අපි diamond තමයි ගන්න. Diamond is a very sturdy structure. It's the hardest substance on earth. Is that clear to all of you? Okay. Now that we discussed that, we can move on to polarity. Can you put a topic, polarity of bonds? अब आप मेरे lesson की वजह कराना होने ने. Did Miss Divya send you 6 and 8 recordings? Sorry, lesson 6 and 8 recordings. Did you all watch the recordings? No, as in you didn't watch or you didn't receive. She didn't share. Oh, okay. You didn't receive. One second. LMS එකට upload කරනවා කියලා කිව්වා and then she didn't send on the group that you can refer to the recordings via LMS. එහෙම මොකුත් message එකක් දාලා තිබුණේ නැද්ද? LMS එකකින් බලන්න පුළුවන් හරි මොනවා හරි දාලා තිබුණේ නැද්ද message එකක්? Wait, I also received the group messages. නෑ නේ. Uh, okay, what is that situation? So, six recording එකයි 8 recording එකයි දෙකම මම last batch එකේ recordings තමයි Miss Divyaට කිව්වේ LMS එකට දාන්න කියලා. So, since she has not uploaded that, මොකද අපි කරන්නේ? I have the recordings. What I will do is, I will send her a message right now. හැමෝටම තියෙනවද LMS access එක තියෙනව නේද? You all have the username and passcode, right? Just let me know that. Do you all have the username and the passcode of the LMS? Okay. So if she didn't send you, maybe she has not uploaded. I'll double check with her and I will make sure that happens tonight. Okay. Because this week හරින ඔයගොල්ලෝ බලලා තියෙන්න ඕනේ මම quiz එකකුත් last කරලා තියෙන්නේ. But මම quiz එක කරන්නේ නැහැ කියලා නම් decide කරා because the attendance is not very high today. But still you should have watched it. So if you didn't receive, that's not your fault, no. So මම දැන් අද රෑ ඇතුළත අනිවාර්යෙන් LMS එකට upload කරන විදියට කියන්නේ ඒක upload කරන්න so that tomorrow you can watch it. So 6th lesson, 8th lesson දෙකම they are from last batch. ගිය batch එකට. ඒතර ඒකේ ළමයි ඒ එක දවසක රෙකෝඩින් එකනේ. දවසක හරි දෙකක හරි රෙකෝඩින්. ඒතර ඒ දවසේ සමහරට ඒ ලෙසන් එකට කලින් තව වෙන ලෙසන් එකක් කරලා තියෙන්නත් පුළුවන්. එතකොට ඕගලන් ඒ හරි තැනට move වෙලා ඒ කියන්නේ you know in the video you move to the right spot and then watch from that. මම හිතන්නේ එහෙම තියෙනවා මොකද 6th lesson එක පටන් ගන්න කලින් අපි වෙන lesson එකක් කර කර ඉඳලා තමයි ඒ දවසේ 6th lesson එක පටන් ගත්තේ. So එතකොට you move to that right spot where the 6th lesson starts and then you start watching from there. Right? මොකද lesson wise නෙවෙයිනේ සාමාන්‍යයෙන් අපි class එක කරත් recording එක යන්නේ දවස ගන්න දවසටනේ. I hope you understood. Did you understand what I meant? Others, I hope you all also understood. So 13th එකත් මම කිව්වේ recordings කරමු කියලා නේද? 13th lesson එක classification. ඒ තුනට මම quiz එකක් කරනවා කියලා කිව්වේ. So අද මම හරිනම් plan කරන් හිටියේ 6th lesson 8th lesson දෙකේ quiz එක අද කරලා 13th lesson එකේ quiz එක next week කරන්න. That was the plan, but this is quite unfortunate. So what we can do is මම තුනම අද රෑ කොහොම හරි upload කරවන්න, right? So I'll make sure that it happens tonight so that whether it's the 6th lesson or the 8th lesson or the 13th lesson that you want, you can access to any of those using the LMS. Okay? All right. Okay. So did you all put the topic polarity of bonds? Give me a second. Okay, Lamai. Now, what is polarity? It's okay, Maria. Api chutta parak vela komat patan gatte because there was this issue with the LMS. LMS එක issue එකක් නෙවෙයි අතරම LMS is up and running and it's strong, no problem. The only problem is that Miss Divya has fallen a little sick. මේ දවස්වල පොඩ්ඩක් අසනීප තියෙන ඉඳ ඔයගොල්ලෝ පරිස්සමෙන් ඉන්න. So she was not able to create today's class link in the LMS. ඔගලන්ට මේ ක්ලාස් ලින්ක් එක එන්නේ මගෙන්වත් මිස් දිවගෙන්වත් නෙවෙයි LMS එකෙන් automated message එකක් එන්නේ. So she has fallen ill and because of that you have not received the link because of that. Kriya create කරලා නැති හින්දා and I can't really say anything because she has fallen sick and I didn't know that. But anyhow, all is well. I think we started at around 7:15, 7:17 වගේ වුණා අපි පටන් ගද්දි. But anyways, we are quickly finishing lesson chemical bonds lesson. Anithika, the other update is Maria. I was just talking to you and I found out that you have not received lesson 6 and lesson 8 recordings. So that I'll discuss with Miss Divya because you are supposed to receive it. ඒක ඇත්තටම හිතන්නේ last Wednesday or Thursday වගේ තමයි ඔයගන්ට ලැබෙන්න තිබ්බේ හරිනා. මම කිව්වා LMS එකට අප්ලෝඩ් කරන්න කියලා. ඒතකොට ඔයගන්ට LMS එකේම බලන්න පුළුවන් වෙන්න. And I asked her to send you a message in the group that you can watch the recording through the LMS, but you have not received that. So I'll have to double check and I'll talk to Miss Divya and I'll make sure, regardless of what, the recordings for the 6th lesson, 8th lesson, and the 13th lesson. ඔය තුනනේ මම recording දෙනවා කිව්වේ. ඒ තුනම අදරාවෙදී LMS එකේ upload කරලා තියෙන්න. I'll make sure that happens, right? So that tomorrow you can watch. And also for the 6th lesson and 8th lesson, they are from the previous batch. ගිය අවුරුද්දේ batch එකට කරපු lesson මේ කරපු මොනවාද recording එක තමයි upload කරන්නේ. ගිය අවුරුද්දේ batch. Yeah. So එතකොට ඒකෙන් ඔයගලන් කියන්නේ දවස recordings එක තියෙන. ඔයගලන් හරි තැනට move කරලා එතනින් එහාට lessons දෙක බලන්න. So just letting you know that. Okay, so that's all the updates. Anyways, polarity. Now, polarity කියන එක ළමයි, this totally depends on electronegativity, right? Okay, so I will take as an example hydrogen fluoride. Okay, so hydrogen fluoride will I'm drawing the Lewis structure. Now you should be able to draw the Lewis structure. Lone pairs with dots and bond with one line. This is hydrogen fluoride. So if you take hydrogen fluoride, which out of hydrogen and fluorine, which one has a higher electronegativity? Which one has a higher electronegativity? It's the hydrogen and fluorine. Okay. I'm getting some answers. Others? Yes, Maria. Yes. Oh, no, only Maria has sent the answer. What about others? Hydrogen or fluorine has a higher electronegativity. Yeah. It's fluorine. Fluorine has a higher electronegativity and hydrogen has a lower electronegativity. What does it mean by higher electronegativity? What is the meaning of high electronegativity? මොකද electronegativity කියලා කියන්නේ? ටක් කරලා කියන්න මට. What is electronegativity? Yeah. Yes. The ability to attract electrons in a bond. Yes. Yes, Chalukya, Maria. Yes, thank you. It is electronegativity කියලා කියන්නේ when an atom is in a bond. On a bond එකක් හැදෙන electrons දෙකක ඉන්නේ. electrons දෙකකින් හැදුනට සමහර වෙලාවට one atom can attract the electrons in the bond towards itself. I will show how that happens exactly, right? Now this is hydrogen fluoride, right? And there's a bond. Bond එකක් හැම වෙලෙම හැදෙන electrons දෙකකින්. Right? So then, in a bond, we don't usually draw the electrons on the bond. But then, now the bond is made from two electrons, right? So we think that this is how the electrons exist. Okay? But in reality, that is not how the electrons exist. The electrons exist like this. So what actually happens is that fluorine has a higher electronegativity. අපි හිතුවට මෙහෙම තමයි ඇත්තටම ඉන්නේ කියලා. ඇත්තටම ඉන්නේ electrons come closer to fluorine. Why? Because fluorine has a higher electronegativity, so the electrons will stay closer to fluorine. Okay. Habai, that doesn't mean hydrogen doesn't have the electrons then. මෙහෙම bond එකක electrons දෙකක් ඉන්නකොට මේ දෙන්න hydrogen because share කළානේ it's a covalent bond, right? Hydrogen ටත් අයිති fluorine ටත් අයිති. දෙන්නටම අයිති. හැබැයි fluorine ට ලං වෙලා ඉන්නේ. Okay? Because fluorine has a high electronegativity, therefore it can attract the electrons in the bond towards itself. Up to that point, did you all understand that? Okay. So, electrons are negatively charged. Now, these two electrons belong both to hydrogen and fluorine, but they're closer to fluorine because fluorine has a higher electronegativity. Right? එතකොට fluorine to ගොඩක් ලං වෙලා ඉන්නේ in the electrons, and we know electrons are negatively charged. Fluorine ට අපි දෙනවා because electrons are closer to fluorine. Fluorine දෙනවා මෙම partial. Full attack නෙවෙයි, partial. භාගයට අට අඳින්නේ. We call it we call this delta negative. නැත්නම් අපි කියනවා partial negative charge කියලා. This partial negative charge is not a real negative charge. ඇත්ත negative එකක් නෙවෙයි. මොකද මේ electrons දෙක fluorine ට අයිති වෙලා නැහැනේ. Electrons belong to both hydrogen and fluorine. හැබැයි fluorine ට ලං වෙලා එන්නේ හින්දා this is like a fake, like a partial negative charge. ඒකට comparatively, hydrogen gets a partial positive charge. Is that clear? Is that clear to you, Lamai? Others? Okay. Chalukya, Dihansa, Maria, Sanjana, Stephanie. Yes, I'll explain again. So, now, hydrogen and fluorine are in a covalent bond. And one bond is made from two electrons that are shared, right? So, share can electrons then hydrogen tat aiti, fluorine tat aiti. Habai fluorine has a higher electronegativity. Therefore, electronegativity කියලා කියන්නේ ability to attract the electrons in a bond towards itself. Therefore, these two electrons will stay close to fluorine. And electrons are negatively charged. So negatively charged electrons are staying very close to fluorine. Therefore, fluorine gets a partial negative charge. This is not a real negative charge. මොකද මේ electrons දෙන ගැලවිලා fluorine ට ආවේ නැහැනේ. It's just that in the bond ටිකක් fluorine ට ළඟින් එනවා. හරිනේ කණ්ඩායම්. Before you become an adult, එදහට එන්න කලින් ඕගොල්ලන් ළමයි විදියට අම්මටත් අයිති තාත්තටත් අයිති. Right? You belong to your parents. Right? But sometimes you can be a little closer to one of your parents. Sometimes you can be more closer to your mother or more closer to your father. Right? So, ඒ වගේ තමයි. මේ electrons දෙන්නටම අයිති. හැබැයි fluorine ට ලං වෙලා ඉන්නවා. Electrons are negatively charged. Therefore, fluorine gets a partial negative charge. It's not a real negative charge. We call it a partial negative charge. Is that clear, ළමයි? Yes. Yes, Stephanie. All good. Maria also wanted to ask me to explain again. That's why. All good, Nene? Okay. So, polarity කියන්නේ මෙන්න මේක. In the same molecule, when charges are separated like this, we call this polarity. මේකට තමයි අපි polarity කියලා කියන්නේ. මෙහෙම charges separate වෙලා තියෙන එක. Can you all draw this? Make example 1 කියලා දාලා මේක draw කරගන්න. We'll write about it, but first draw, please. Quickly draw. Done drawing, Lamai? Shall we write something underneath? Okay, make a draw can very well. Okay. So, math tekkamal yagan. I hope you're writing with me. Madhuri, experiment yana මොකද අපි ටටා ගාලා move වෙන්න ඕනේ අපිට චුට්ටක් පරක්කු වුණානේ. Just let me know if it's too fast, huh? මෙතන ළමයි ගොඩාක් ලිව්වට ඇත්තටම පොඩ්ඩයි මම දැන් කියපු ටිකම තමයි තියෙන්නේ ආ. And also මම short sentences වලට break කරේ so that it's easy. මේක අනිවාර්යෙන් ලියන්න ඕනේ. මොකද even later when you want to study and you look at the note, it has to be very clear. No, that's why. Quickly write this. Quickly write. And then I'll show you 2 other molecules and we'll be done with that part. Done, Lamai? Give me a thumbs up if you finish writing. Okay. Now, example 2 is... Class is recording now. Okay. Example 2 eකට, if you take something like F2. This is the fluorine molecule F2. Right? F2 හැදෙන්නේ මෙහෙම F දෙන්නෙක් ඉන්නවා fluorine දෙන්නෙක් ඉන්නවා ඒ දෙන මැද covalent bond එකක් තියෙනවා and there are lone pairs like this. So a covalent bond is formed by sharing two electrons, right? So එතකොට මෙන්න මෙතන there are two electrons. Okay, there are two electrons shared. Now, if you take fluorine and fluorine, which one has a higher electronegativity? One fluorine does a high electronegativity එකක් තියෙනවා. Which fluorine has a high electronegativity? Yeah, because they are both fluorine. Fluorine ගත්තොත් එකම electronegativity එක තියෙන. මෙයාටත් එකයි මෙයාටත් එකයි. Right? So if you take fluorine, since both are fluorine, they both have the same electronegativity. And because of that, ඒ දෙන්නම electrons දෙපැත්තට අදින එකම force එකෙන්. මේක ළමයි ඔයගොල්ලෝ සිම්පල්ම තේරුම් ගන්න විදිය මොකක්ද දන්නවද? කම්බා දින තරගයක්. Right? You know, tug of war. In English, we call it tug of war. මම මේක මේ ළඟදී කොහෙද දැනගත්තේ, but සිංහලෙන් මම දන්නේ වැඩි ඉංග්‍රීසි වර්ඩ් එක, but සිංහලෙන් කමා දිනවා. ඉංග්‍රීසි වල ඒකට කියන්නේ tug of war ලු. But anyways, මෙතන hydrogen and fluorine හිටියාම fluorine electronegativity වැඩි. ඒ කියන්නේ එයා strong කියලා අපි හිතමුකෝ. එයා කඹේ වැඩිපුර අදිනවා. ඒක කඹේ කියන්නේ electrons දෙක. එහෙනම් electrons දෙක fluorine පැත්තට වැඩිපුර යනවා. මෙතන fluorine දෙන්නම they both have the same electronegativity. ඒක නේ දෙන්නම දෙපැත්තට එකම force එකකින් අදින්නේ. ඒක නේ කබේ මෙහෙට යන්නෙත් නෑ මෙහෙට යන්නෙත් නෑ. So electrons are not moving this way or this way. Okay? So therefore මේ වගේ එකකට අපි කියනවා there is no like partial negative, partial positive, right? So we call F2 a non-polar molecule. මෙතන polarity නෑ. Right? So මේක තඳගෙන ළමයි and we'll write. We call F2 a non-polar molecule. Quickly write this, make it really fast. Others done? Okay, I'll give you like 1 more minute. Okay, now I think that is enough time. So let's move on to H2O. So that is my third example. මෙයාව මට ඕන වෙනවා ඊළඟ part එකට. Right? So H2O. So H2O වල ඔයගලන්ට do you all remember drawing H2O the Lewis structure? Can you turn to that page? මෙහෙම එකක් නේද draw කරේ මතකයිද? මෙහෙම H. Do you all remember drawing something like this? Others? Others? All right. So මේකම මම angle එක වෙනස් කරලා අඳිනවා. Same thing, just I change the angle. O H H and like this. Oxygen has 2 lone pairs. Now there are 2 bonds now. So bonds දෙකක් ඉන්නකොට මේම මේ bond එකේ electrons දෙකකින් හැදිලා තියෙනවා. මේ bond එකත් electrons දෙකකින් හැදිලා තියෙනවා. මෙහෙම තියෙනවා කියලා අපි හිතුවට අර HF molecule එක වගේ තමයි. If you take oxygen and hydrogen, which one has a higher electronegativity? Oxygen, the hydrogen. Which one has a high electronegativity? Others? Oxygen or hydrogen? Oxygen or hydrogen? Oxygen. Oxygen na higher electronegativity is oxygen. Periodic table එකේ ඔයා left to right යන්න electronegativity වැඩි වෙනවා. And noble gases don't have electronegativity. So, අපි හිතුවට මෙහෙම electrons ඉන්නවා කියලා. In reality, electrons are closer to oxygen, like this. Okay, electrons දෙන්නම oxygen ට ලං වෙලා ඉන්නේ. දැන් මම කලින් කලින් HF වල electrons අඳින්නේ මෙතන අඳින්නේ නැහැ. And then නැතත් දැන් ඔයගොල්ලන්ට හිතා ගන්න පුළුවන්. If you take oxygen and hydrogen, oxygen has a high electronegativity. So electrons are staying closer to oxygen. Therefore, oxygen gets a partial negative charge and the two hydrogens get a partial positive charge. So, water H2O is also a polar molecule, right? So, H2O or water is a polar molecule. Is this clear to all of you, Lama? Give me a thumbs up. All right. Quickly draw and write this. Make it fast, huh? Quickly draw and write this. And we'll move on to intermolecular bonds. You can even put the next topic. Quickly. Okay, Laman. Intermolecular bonds. Intermolecular bonds, let's first, I'll first explain and then we can write. Okay. Intermolecular bonds are අපේ syllabus එකේ තියෙන්නේ we have to learn about water. Right? Water is the only example that we need to learn about. Right? So, this is a water molecule. This is one water molecule. Right? And I will draw another water molecule. Something like this. I think I will just draw one. එක එක direction එකට තියෙන්න පුළුවන්. The angle can change. The angle can change. Like this. So this is one water molecule. This is another water molecule. Now here there are 3 water molecules. Now we know always positive and negative are attracted, right? Positive, negative, they are always attracted. Here, හැබැයි negative, positive නෙවෙයි තියෙන්නේ. These are partial negative charge and partial positive charge. But ළමයි, partial or full positive නම් positive, negative නම් negative. Here what happens is that this partial negative and the partial positive are attracted. So there's an attraction between the partial negative and the partial positive. Here also between the partial negative and the partial positive, there's an attraction. I can draw another like a water molecule. Let me draw one. අපි draw කරමු. එක එක පැති වල තියෙන්න පුළුවන්. මම randomly draw කරන්නේ. Let's say like this. Like this. Here partial negative, partial positive, partial positive. Here we can see this is partial negative, this is partial positive. So there will be an attraction here also. Likewise, if you take water, everywhere there are these attractions between the partial negative oxygen and the partial positive hydrogen. This is what we call intermolecular bonds. These are not real bonds where electrons are shared. අපි ගත්තොත් මෙන්න මේක ළමයි. මෙන්න මේක ගත්තොත් මේ electrons share වෙලා හැදිච්ච covalent bond එකක්. මෙයත් එහෙමයි covalent bond. Covalent bond, covalent bond, covalent bond, covalent bond, covalent bond, covalent bond. Covalent bonds were electron share වෙලා හැදෙන්නේ. These are not covalent bonds. These are just partial negative ions and partial negative atoms and partial positive atoms in the molecules. Because of polarity හැදෙන්නේ, there are attractions. මේවා partial negative, partial positive තියෙන attractions විතරයි. These attractions are what we call intermolecular bonds or intermolecular forces. Okay? Is it clear to you? Give me a thumbs up if it's clear, Lama. Others? Others? Okay. So we call these intermolecular bonds, intermolecular forces, or intermolecular attractions. Yes, I'll explain again. ඔන්න බලන්න අපිට එක water molecule එකක් තියෙනවා and we already learned about this. Oxygen is partially negative and hydrogens are partial positive. මෙතන තව water molecule එකක් තියෙනවා. There also oxygen is partially negative and hydrogens are partially positive. Here we have another water molecule. Again, oxygen is partially negative and hydrogens are partially positive. Here also, oxygen partial negative, hydrogen partial positive. So partial negative, partial positive are not real charges. Are electrons, oxygen to lang vela inne hinda in charges, right? However, partial hari, full hari, mewa negative, positive ne, and always negative, positive are attracted. Here, this oxygen is partial negative, this hydrogen is partial positive. They will form an attraction. Here oxygen partial negative, hydrogen partial positive, they will form an attraction. Here oxygen partial negative, hydrogen partial positive, they will form an attraction. These attractions between partial negative and partial positive atoms in a polar molecule, ඒවට තමයි අපි intermolecular bonds or attractions කියලා කියන්නේ. මේක ඒවට තමයි අපි intermolecular bonds or attraction කියන්නේ. Is that up to that point, is it clear, Charlotte? Okay. So, then the next part is Charlotte. So here, මේ bond එක ගත්තොත් එimhe electrons share වෙලානේ හැදෙන covalent bond. Here also the same. Here also the same. අපි මේව ඉගෙන ගත්තානේ last week. මේව covalent bonds. Electrons share වෙලා හැදෙන. හැබැයි මේව covalent bonds නෙවෙයි. These are just attractions. අපි intermolecular bonds whatever bonds නෙවෙයි, just attractions. So they are not as strong as the covalent bond, just attractions only. But they are pretty good. සාමාන්‍යයෙන් හොඳ strength එකක් තියෙනවා. හැබැයි covalent bonds තරම් strong නෑ. Is that also clear, Chalukya? Okay. So let's write. First, can you all draw this while I write? ලියලා මාත් එක්කම draw කරලා මාත් එක්කම ලියන්න. So just letting you know, I think my last week එකක් කිව්වා මෙතනින් පස්සේ ඔයගලන්ට තියෙන ඔක්කොම notes වගේ except for I think 2 or 3 lessons, will you grade 10 ඔක්කොම lessons you have PDF notes. අනිත් එක ළමයි ගිය batch එකට වඩා මම තව සමහර notes ගොඩක් සාමාන්‍ය අපි hand write කරන ඒවාත් මම PDF දෙන්න decide කරා. මොකද you know the science syllabus is very huge, right? And time is a big problem. And අපි සාමාන්‍යයෙන් නිකන් ඔහේ ටට්ටක් ගාලා කරගෙන යනවා නෙවෙයිනේ. We like discuss everything very much, and I check if all of you understood, and even if you have not understood, we discuss that again. Even if one of you didn't understand and you let me know, I make sure that we discuss, right? Because it's very important. මොකද අපි group class එකක් නේ, maths class එක නම් ඔයගලන් කරාද නැද්ද මට අදාළ නැහැ කියලා මට ඕන විදිහට උගන්වන්න පුළුවන්. එහෙම කරන්න බෑ. Even in a math class it's not right. But what I mean is, in a group class we are a small group. So that is why I want to ensure all of you understand, right? That's the whole point, right? So ඒ වගේම ඔයගලන්ටත් it should be easy for you to let me know if you didn't understand, because math class එක වගේ නෙවෙයි, in a group class it's easy, right? To communicate also. So එතකොට අපි අර ගොඩාක් in detail හැම කොටසක්ම discuss කරනවානේ, to make sure that you understand and we have no doubts. එතකොට අපිට normal lesson එක කරන්න time එකට වඩා වැඩිපුර time යනවා. මගේ පහුගිය batches හැම එකම that was the normal situation. But I don't plan to change that. මොකද I mean භාගිට කෙනගෙන වැඩක් නැහැනේ. and අන්තිමට උගන්ටත් නැහැ මටත් නැහැ exam එකටත් කිසි උදව්වක් නැහැ. එහෙම වැඩක් නැහැ. Whatever we learn, we have to make sure we learn it with zero doubts. Everything should be clear. And also, so that like even for the exam, ඔයගලන් පාඩම් කරද්දී උගන්ට කිසි ඩවුට් එකක් එන්නේ නැති වෙන්න. So ඒක හින්දා මේ අපිට වැඩිපුර time යනවනේ. ඒකින්ද මම ගොඩක් notes දැන් for an example in grade 10 second book there's a lesson called changes in matter. It's one of the biggest chemistry lessons we have in the O-level syllabus. It's very very important. So ගියා හැම batch එකකම මේ lesson එක මේ මම hand write කරා. නෑ ගිය හැම batch එක නෙවෙයි ගිය batch එකට කලින් batches පහක්ම hand write කරා. but ගිය batch එකේ මම PDF note එකක් දුන්නා. මොකද ඒක time save කරන්න ඕනේ හින්දා. දැන් ඔයගලන්ට ඒ PDF note එක මම දෙනවා. So ඒ වගේ ගොඩක් ඒවා මම PDF notes විදිහට කරා. I hope it's not too troublesome for you to take a print out. මොකද print out එකක් ගන්න එක ඇත්තට ලොකු එකක් නෙවෙයි. හැබැයි අනිත් පැත්තට ඒකෙන් අපිට ලොකු support එකක් එනවා to save time. So time is our biggest enemy, right? So just letting you know that ගොඩක් ඒවා අපි hand write කරන්නේ නැහැ ඉස්සරහට. මේ වගේ ගොඩක් draw කරන්න වගේ තියෙන ඒවා and also in the future do we have any one or two lessons we have to handwrite. Other than that everything else is a PDF, right? So just prepare for that. Prepare කියන්නේ මෙහෙමයි උවමගේ print out එකක් ගන්න. දැන් ඉස්සරහට එවන්නෙත් නෑ ඔක්කොම LMS එකට තමයි දාන්නේ. උගන් පොඩක් LMS එක log වෙලා වැඩ කරනවාද එහෙම කියලා චුට්ටක් බලන්න. For tomorrow or whenever possible. මොකද අර lesson 6 8 13 ඒ ටිකත් තමයි LMS එකට තමයි දාන්නේ. So පොඩ LMS එක log වෙලා බලන්න whether it's working. And if not let me know so that we could see what is wrong. Because LMS එකේ තම මොකද ඔක group එකවල දාන එක හරි කරදරයක්, right? ඊට වඩා ලේසි LMS එකේ ඔක්කොම තියෙන ඔයගලන්ට refer කරන්න. අදින් පස්සේ ඔක්කොම recordings උත් අදින් පස්සේ නෙවෙයි ජුලයි වල ඉඳන් ඔක්කොම recordings උත් දාන්න LMS එකට. ඔයා log වෙලා recording section එකට ගියා. ඔයා absent වෙච්ච දවසේ recording එක බැලුවා. Right? Even notes, everything so that it's easy for you actually. So ඔයගා recording ඉල්ලන්න කරදරේ ඊට පස්සේ මිස් දිව්‍යයි වෙනකම් බලන් ඉන්න ඕනේ. මිස් දිව්‍යයි වන්නත් මම අප්ලෝඩ් කරන්න ඕනේ. so මම අප්ලෝඩ් කරනකම් ඉන්න ඕනේ. අර ඒ තැන තියෙන ඒ පොඩි ස්ලෝ වෙන තැන් ඔක්කොම හරියනවා ඔය වැඩේ. So just check if your LMS login is working. මේ හැම එකකම intermolecular bonds නෑ ළමයි. සමහර ඒවාවල විතරයි තියෙන්නේ. So water has intermolecular bonds නේ. Because water has intermolecular bonds, water at room temperature stays as a liquid. ඒකට හේතුව තමයි ඒගොල්ලන්ගේ intermolecular bonds තියෙන්නේ. Okay? And also water වල තව special properties ටිකක් ඇවිල්ලා තියෙනවා. ඒක දැන් ලියන්න මම explain කරන්නම්. මේක ලියාගෙන I will explain. But quickly write, huh? Okay, done lamai? Done writing this? Others? Anybody who needs more time? Okay, I'll give you like 1 more minute. Make it fast. හරිනේද ළමයි? So here, yes, the last point, what it means is that I told you හැමෝටම නැහැ intermolecular bonds, right? But water has. Because of that, water has some special properties, like it has a high boiling point, it has a high boiling point කියන ළමයි සාමාන්‍යයෙන් ගොඩක් liquids ඉක්මනට රත් වෙනවා. Boil වෙනවා. Like if you take alcohol, boils faster, right? At a lower temperature. පොඩ්ඩක් රත් කරත් boil වෙනවා. Oil වගේ ගත්තොත් පොඩ්ඩක් රත් කරත් boil වෙනවා. Water එහෙම නැහැනේ. ටිකක් වෙලා රත් කරන්න ඕනේ. Water's boiling point is 100 degrees Celsius. So compared to other liquids, water has a high boiling point. High specific heat capacity means අපි මේ heat ගැන කතා කරනවා in grade 11. But simply කිව්වොත් එහෙම water වල temperature එක 1 degree එකකින් වැඩි කරන්න ගොඩාක් heat දෙන්න ඕනේ. ටක් ගාලා temperature එක වැඩි වෙන්නේ නැහැ. Right? High specific heat capacity means it has a very good capacity for heat. ගොඩාක් heat එයාට ගන්න පුළුවන් capacity එක වැඩි. අරන් බැරිම තැන තමයි 1 degree එකක් temperature එක වැඩි කරන්නේ. I may have explained this in first lesson. Some people have අපි කියන්නේ emotional capacity එක වැඩි කියලා. Emotional capacity එක වැඩි කට්ටියට life එකේ ගොඩාක් දේවල් කොච්චර දේවල් වුණත් ඒගොල්ලන්ට එකපාරට දුක හිතෙන්නේ නැහැ. Let's say emotionally ලොකු capacity එකක් තියෙන කෙනෙක් කියලා and එයාට ගොඩාක් negative දේවල් වෙනවා කියලා එක දිගට. So negative දේවල් වෙලා එයාට capacity එක වැඩි හින්දා එයාට ගොඩාක් ඒවා උනාට tolerate කරන්න පුළුවන්. Tolerate කළා බැරිම තැන තමයි maybe like breakdown or අඬනවා හරි මොන හරි වෙන්නේ. Right? ඒ වගේ තමයි water heat ගොඩාක් අරගෙන බැරිම තැන තමයි temperature එක 1 degree එකක් වැඩි කරන්නේ. Some are liquids තියෙනවා they have a low specific heat capacity. හරියට නිකන් low emotional capacity එකක් තියෙන කෙනෙක් වගේ. එයාට පොඩි negative දෙයක් වුණත් breakdown වෙනවා. හරි අඬනවා හරි මොන හරි. ඒ වගේ තමයි සමහර liquids they have a low specific heat capacity. Heat චුට්ටක් ආවත් එයාගේ temperature එක වැඩි වෙනවා. But water එහෙම නැහැ. Water has a higher density than ice. Now water, when you cool it, it becomes a solid. That solid, we call it ice, right? Generally, lamai, solids වල density වැඩි liquid එකට වඩා. ඒක පොඩ්ඩක් තේරෙනවනේ අපිට solid එකේ density වැඩි liquid වලට වඩා. හැබැයි water වල liquid එකේ density වැඩි solid එකට වඩා. Therefore, water has a higher density than ice. That is also because water has intermolecular bonds. Okay. So these are some special properties that water has because of intermolecular bonds. All right. Then, Lamai, there are a few. Can you put a topic? Properties of ionic and covalent. Now, where did I draw this? Huh? So here we are going to compare some, how do I move this? Compare some properties of ionic and covalent bonds. So, one second, Lamai. Can't move this. Matakama liana kome. Matakama liana, and then we can discuss. Huh? Quickly write. I hope you're writing with me. Quickly write this, Lamai. Done, Lamai? Give me a thumbs up if you have finished. Okay. All right. Can you all okay. So this is actually all for the lesson. Meaning had monat nahe and when muku tahanna devalut nahe, this is all, right? So before we move on, I have a small question for you, right? Question kila dala liyagan. Huh? Draw the Roman number 1. So carbon tetrachloride क्या नाम है CCl4. So आप normal draw कर फिर you have to draw how it is formed. Then draw the dot and cross structure. Then draw the Lewis dot diagram. आप यार इगन गाते diagrams चुनें. And finally draw the Lewis structure. This is for carbon tetrachloride. For your information, carbon tetrachloride is CCl4. මැද කාබන් එකක් ඉන්නවා වටේ ක්ලෝරින් 4ක් ඉන්නවා. Okay, මැද කාබන් එකයි වටේ ක්ලෝරින් 4යි. Can you all quickly start drawing? Make it really fast. Quickly. As soon as you're done, put in the chat box. Okay? Make it fast. Done, Lamin? Who needs more time? Okay. I'll give you all of you. Seems like all of you have not done yet. 4 minutes. 3-4 minutes වගේ තව දෙන්නම් ඉක්මනට ඉවර කරන්න. If you have any questions, you can ask. Huh? I just have my camera off because of the connection problems. But still, I'm right here. If you have any questions, you can ask me in the chat box or unmute, and I'll answer. Make it fast. Okay, Lama. I think that is enough time. Were you able to finish? Give me a thumbs up, please. Not yet? Are you all still doing? ඉවර කට්ටිය thumbs up එකක් දෙන්න බලන්න. Senudi, Chalukya, Dihansa, Ranmihi, Maria, Stephanie. Did you all finish? Or still doing? Can you all hear me, Lamai? Still doing? Why? Dihansa, Senudi, Ranmihi, Chalukya, Stephanie, what about you? Okay, let's discuss and it's okay. So you can be still doing, but let's discuss. So carbon tetrachloride means there is one carbon and 4 chlorine atoms, right? Okay. So carbon gathama electronic configuration is 2,4. So if you take, let's say this is the nucleus. Let me draw like circles. First energy level, and this is the second energy level. This is carbon, no? This is carbon. So first energy level has 2 electrons, second energy level has 4 because carbon wala electronic configuration 2, 4, right? So 1, 2, 3, 4. So this is carbon. Now I will draw one chlorine molecule. Eka chlorine ekak gatthoth ehema, this is chlorine. This is the first. Can you tell me the electronic configuration of chlorine, Lamai? What is the electronic configuration of chlorine? Hmm? 287. Yeah, so I'll draw 2. And then 8 is 1, 2, 3, 4, 5, 6, 7, 8. And outermost energy level, okay, there is 1, 2, 3, 4, 5, 6, 7. මෙයාට විතරක් එක්කෙනෙක් නැහැ. This is just one chlorine, right? එක chlorine ගෙනෙක් මෙන්න මෙහෙම දැන් මෙයා ඔක්කොම lone pairs තියෙනවා. Everybody has a pair. මෙයා විතරක් තනියෙන්. ඒ තනියෙන් ඉන්න එක්කෙනා මෙතන තනියෙන් ඉන්න කාබන් එකක් එක covalent bond එකක් හදනවා. ඒ වගේ හතර පැත්තෙම there are 4 chlorine atoms coming and forming covalent bonds with the 4 electrons of carbon. So that would look something like this. මෙන්න මේ final එක ඇඳන හොඳටම ඇති. Like this, right? බලන්න මෙහෙම carbon ඉන්නවා. ඔන්න එක chlorine ගෙනෙක් මෙහෙම ඇවිල්ලා දැන් මෙයාටත් මෙතන මෙයා එක electron එකයි මෙතන මෙයා එක electron එකයි. So they will form a covalent bond like this, right? Where they share electrons. ඔන්න electrons එක share කරලා. ඒ වගේ තව chlorine එකක් එනවා. මේ chlorine එකේ මම මේ chlorine එකේ I will rotate this a little. And I will have to erase this because there's no space. මේ ක්ලෝරීන් එනවා මෙතනට ඇවිල්ලා මෙන්න මේ ඉලෙක්ට්‍රෝන එක ෂෙයා කරනවා. So here chlorine electron එකයි carbon එක electron එකකුයි they will be shared. Actually that is what I asked Maria. ඒ කියන්නේ carbon atoms ටික වෙන වෙනම ඇඳලා එක අඳින්න තමයි මම අහුවේ. But still මෙහෙම ඇඳත් කමක් නැහැ. Right, because now we are just discussing, so මෙහෙම ඇඳත් ඇති. මොකද chlorine චුට්ටක් අඳින්න complicated නේ. Complicated can it's a little bit of a big molecule. Then this is again chlorine. එයා මෙන්න මෙතනට එනවා. ඇවිල්ලා මෙන්න මෙතන electrons share කරනවා. So here electrons are shared. And then it will come here. And here electrons are shared. Is this clear to you, Lamai? How electrons are shared, is it clear to you? Give me a thumbs up, please. Others? Okay. Now we have to draw the dot and cross, Lewis dot diagram and Lewis structure. You know, මේ dot and cross, Lewis dot diagram and Lewis structure මේ ඔක්කොගෙම අපි outermost energy level එක විතරයි බලන්නේ, right? So this is how you draw the dot and cross. දැන් carbon ගේ ඇතුලේ දෙන්න ඉන්න එක වෙනම කතාව, but එළියේ ඉන්නේ 4 දෙනයි නේ. Carbon ගේ එළියේ ඉන්න 4 දෙනෙක්. I will show carbon with dots. ලොකුවට අඳිනම එක පේන්න. Carbon dot 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 dot. Chlorine ගත්තොත් chlorine ගේ මෙතන ඇතුලේ දෙන්නෙක් ඉන්නවා, මෙතන 8 දෙනෙක් ඉන්නවා. අපිට ඒවා අදාළ නැහැ. We only care about the outermost energy level, and in the outermost energy level 2 4 6 මෙතන ෂෙයා කරන දෙන්නගේ එක්කෙනෙක් chlorine. So 7. Let's see. මෙම chlorine ඉන්නවා 1 2 මේ lone pairs 3 4 5 6 ෂෙයා කරන දෙන්නගේ එක්කෙනෙක් chlorine ට ආйти. ඒ වගේ මෙතනත් chlorine ඉන්නවා. Like this. මෙතනත් chlorine ඉන්නවා. These are lone pairs. Crosses වලින් පෙන්නන්නේ chlorine. මෙතනත් chlorine ඉන්නවා. Like this. This is a dot and cross diagram. Then the Lewis dot diagram. Lewis dot diagram එකේ අරකම තමයි, but everything is in dots, right? Carbon ඉන්නවා, chlorine, 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 chlorine. So මෙතන dots මේ එක්කෙනෙක් carbon ගේ එක්කෙනෙක් chlorine ගේ එක්කෙනෙක් carbon එක්කෙනෙක් chlorine එක්කෙනෙක් carbon එක්කෙනෙක් chlorine. And then chlorine also has its own electrons, no lone pairs. මෙතන එක lone pair එකයි, lone pair, lone pair. Here lone pair, lone pair, lone pair. Here lone pair, lone pair, lone pair, and here lone pair, lone pair, lone pair. Then the Lewis structure is the same as the Lewis dot diagram. The only difference is that bonds are shown with lines. So if you take carbon, chlorine, 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 මෙතන එක bond එකක් I show with one line. Here one bond show with one line. Here one bond show with one line. Here one bond show with one line. And the lone pairs I show with dots. 1, 2. This is another lone pair. This is another lone pair. මෙයාගේ මේ lone pair, lone pair, lone pair. මෙයාගේ lone pair, lone pair, lone pair. මෙයාගේ lone pair, lone pair, lone pair. Is this clear to you, Lama? Give me a thumbs up, please. Give me a thumbs up, please. All right. Okay. So that's all. Let's wrap up for today. Is everything we did today clear to all of you, Lamai? Okay. So, mama other rack umari 6th and 8th lessons upload kala tiyana LMS ekata. So that you can watch them and we will do the quiz next week and then I'll also upload the 13th lesson. So check your login details and see if it's working. All right. Okay, then let's wrap up and let's see each other next week, which is 21st of July. Okay. All right. Until then, have a great week and good night, Lamai.
Good night, teacher. Have a great week.
Okay, you too. Bye.